Okay, here we are on to our next problem. We have the inside of a funnel of height 10 inches. The whole height of the funnel is 10 inches. Has cross-sectional solids. Has circular cross-sections, circles. Cross-sections as shown in the figure above. At height h, the radius of the funnel is given by the following equation. So that's the radius, where h goes between 0 and 10. The units of r and h are inches. It says find the average value of the radius. So we know when we see the word average, it's either going to be rate or value, and they want value. So it's going to be 1 over the length of the interval, which is 10 minus 0. And the integral of that from 1 to 10 of the function itself. And this is a non-calculator one, so we have to work it on out. So it's 1/20th of 3 plus h squared dh. So when I'm going to solve this problem out, the first thing I'm going to do, I'm going to take out the 1/20th. So I've got 1 over 10 times 1 over 20. That's 1 over 200. The integral from 3 plus h squared dh from 0 or from 1? We wrote down 1 on that problem right there. You got me. From 0 to 10. Now normally when they ask you to work out an integral, they'll start you out at 0 so you don't have to do any work on it. So this is equal to 1 over 200. Now I'm going to integrate that, which would be 3h plus 1/3 h to the third from 0 to 10, which is equal to 1 over 200. I know I can dump the 0 parts. I'm just going to fill these on in. 30 plus 1/3, 10 to the third. I can leave it like that. I don't have to go any farther if I don't want to. I feel the need. 1 over 200, 30 plus 10 to the third is 1,000. So that would be 1,000, 1/3 times 1,000. And I'm going to leave it there. There's no sense doing more work to find out what the answer is going to be. Okay, so I found the area. The next thing is, and this one's a little tricky because is this a cross-section or is this a volume of rotation? So look at the shape, and we know it makes the outside edge. So this one is going to be a volume of rotation. So it's going to be pi. Whoop. It's going to be pi. The integral, probably from 0 to 10, of ya minus ya. Okay, now, how many curves am I rotating? Well, I'm only rotating one curve, so I don't need the second ya. The axis I'm rotating it around is the center, so I don't need this. So it's just going to be this equation right here, which is going to be pi times the integral from 0 to 10 of 1 over 20 times 3 plus h squared dh. Now, of all the integrals they've done, this is kind of the more challenging of the one they've had you to do because they've got this squared on the outside. In order to solve this, I'm going to have to square things out. So first thing I'm going to do is going to square this 1/20th, and that's going to become 1 over 20 squared is 400. The integral from 0 to 10, and now I've got to square this. Now remember, when I'm squaring it, I've got to FOIL it. If I mess that up, it's okay. I'm going to lose a little bit of the points, but I'm going to FOIL it, and it gives me 9 plus 6h squared plus h to the fourth from 0 to 10. Oh, who wrote that down? dh. So now I'm ready to integrate away. I'm going to keep my pi over 400 outside. And I'm going to integrate, and I'm going to get 9h plus 6 over 3, which is 2h to the third. How do I know? Bring that down, I get 6h squared plus 1/5 h to the fifth from 0 to 10. And once again, that 0 isn't going to come into play because it's not part of the answer. So when I work this out, I'm going to get pi over 400 times 90 plus 2 times 10 to the third plus 1/5 10 to the 5th is the answer. I'm not going to simplify it. I'm going to leave it just like that. That's the correct formula for area. If you had trouble even to start the problem, always integrate when we're finding volume. And if you had trouble figuring out how to square this thing, make it up. I would have made it up into 9 plus h to the 4th and tried from there. Okay, so this question says at the instant the height is 3 inches. The radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. So when the height is 3, at that time, dr dt equals negative 1/5 because the rate is going down. At this instant, what is the rate of change of the height of the liquid with respect to time? So it looks like I have two rates that are related. I need an equation that relates quantities, which is right here. R equals 1/20th. 3 plus h squared, which means to find how the rates are related, I'm just going to take the derivative of this statement right here. So this becomes dr dt equals 1/20th derivative of 3 is gone, derivative of h squared is 2h dh dt. And now that I have this piece of information, I could probably fill in everything I have to find out what dh dt is going to be. So dr dt is negative 1/5 equals 1/20th. 2, do I know h? Yep, that's 3. dh dt. So in doing it really quickly, dh dt would be equal to, I've got a negative, I've got a 1 and a 5. The 20 moves to the other side and goes to the top. This 6 goes to the other side and goes to the bottom. I could leave it like that, but it shortens into negative 20 over 30, which reduces down to negative 2/3. I could leave it like that. I do not need units of measure because none of them were indicated on the problem. So this is what they consider the hardest problem on this one because it had so much different work to work on out and so many different hidden tricks. Like they intentionally use the word cross-section right here. It's the first time they've done that to try to confuse you whether to do cross-sections or whether to do volume of rotation. But they said the cross-sections were circles. We've never seen a cross-sectional solid that had a full circle. That's how we know this is the way to go with this one. Okay, one more problem coming.